Okay, welcome student to this part 2 of this chapter 1, which is a chapter on the real numbers. Okay, now here we'll be discussing with the first problem from this chapter on the problem 1. Use Euclid division algorithm to find the HCF of the following pairs of number, with the first one of 18 and 24. Now, out of these two numbers, 24 is bigger, 18 is smaller. Therefore, we'll take A by 24 and B to be 18. Okay. Now, 18 is the divisor. You take as divisor and 24 as dividend. 18 multiply 1 is 18, leaving remainder 6. Now, this 6 you take as a divisor, 18 as the dividend. 6 multiply how much is 18? 6 multiply 3 is 18. Giving you 0 as the remainder. Hence, the last divisor here, 6, will be the HCF of these two numbers. Okay. Now, here, applying Euclid division algorithm, you will write in this way: 24 is equal to 18 multiply 1 plus remainder 6. Okay. Now, take this 18 as the dividend, 6 as the divisor. 18 is equal 6 multiply 3 plus remainder 0. Here remainder is 0, therefore the algorithm will stop here and the last divisor will be taken as the HCF, that is 6. The last divisor will be their HCF. Okay. The second number, the same thing. You take A by a bigger number, which is 70, and B by a smaller number, 30. Now we divide 70 by 30, you will go with 2, 60. Remainder is 10. 30 divided by 10, you will go with 3. Again, remainder 0. Since remainder is 0, the algorithm will stop here, and the HCF will be the last divisor, which is 10. Okay. The third one, you'll take A by a bigger number, 924, and B smaller number, 714. Apply again EDA. We have 94 is equal 714 multiply with 1, remainder 210. Then 714 divide by 210, you'll go with 3 is 630, remainder is 84. Again you take 210 divide by 84, you'll go with 2 is 168, remainder is 42. Now 84 divide by 42, you go with 2 is 84, remainder will be 0. Hence the HCF will be the last divisor, which is 42. Clear? Next, number 4. Here 190 is greater than 100, therefore we'll take A by 190 and B as 100. When you divide 190 by 100, you will go with 1 is 100, remainder is 90. 190 is equal 100 multiply 1 plus 90. And then again you take this 100 as the dividend, 90 as the divisor. 90 multiply 1 is 90, remainder will be 10. Again you take 90 as the dividend, 10 as the divisor. 10 multiply 9 is 90, leaving a remainder 0. Now what is the last divisor here? It is 10, hence the HCF will be 10. Clear? Next, number 5. Here also you will take A by a bigger number, 120, and B by a smaller number, which is 105. Now 105 multiply 1 is 105, remainder will be 15. Again take 15 as the divisor, you divide 105, you will go with 7 is 105. Then this 15, the last divisor, will be the HCF of 105 and 120. Number 6. 1385 is bigger than 155, therefore you will divide 1385 by 155. You go with 8 is 1240, remainder will be 145. Again the next step, 145 you take as the dividend, 155 as dividend, 145 as the divisor. You go with 1 is 145, leaving 10 as remainder. 145 multiply 1 plus remainder is 10. And then Again, you take 145 as the dividend, 10 as the divisor. Divide 145 by 10, you'll go 14 is 140, leaving 5 as the remainder. Now 5, lastly you take 10 as the dividend, 5 multiplied 2 is 10, leaving remainder 0, and this last divisor 5 will be the HCF of 155 and 1385. Number 7, 4641 and 4095. 4641 is greater, therefore we'll take A by 4641 and B is 4095. When you divide the dividend by this divisor, you will go with 1, 4095, leaving remainder 546. Okay, now we take this as the dividend, 4095, 546 as the divisor. You will go with 7 is 3822, leaving remainder 273. Okay, the last step from here, taking 546 as the dividend and 273 as the divisor. 546 divided by 273 will go with 2 is 546 and leaving remain 0. Hence this 273, the last divisor, will be the HCF of these two numbers. Clear? Next, with the number 8, 9367 is greater than 3451, therefore A will take by bigger number, B by a smaller number. Okay, when you divide this by 3451, you will go with 2 is 6902 plus remainder 2465. Next step, 3451 as the dividend, 2465 as divisor, multiply with 1 is 2465, leaving remainder 986. Third step, 2465 as the dividend, 986 as the divisor. When you divide this, you will go with 2 is 1972, leaving remainder 493. Now the last step will be 986 divided by 493, will go with 2 is 986, leaving remainder 0. Therefore the HCF of these two numbers will be the last divisor, which is 493. Now coming to the next, number 2, using the EDA, find the HCF of the following numbers. Here in number 2 we have 3 numbers. You have to find the HCF of these 3 numbers. Now to find the HCF of these 3 numbers, what you will do, you consider the first 2 numbers and find the HCF between them. After getting the HCF of these 2 numbers, you find again the HCF with the third number, and whatever you are getting the HCF from there will be the HCF of all these 3 numbers. Clear? Now let us proceed with this. You take the first 2 numbers, 296 and 999. Since 999 is greater, therefore we'll take A by 999, B by 296. Apply EDA successively. We have 999 is equal to 296 multiply with 3, giving you remainder 111. Again 296 divided by 111, you'll go with 2, giving you remainder 74. Third step, 111 divided by 74, you'll go with 1, giving you remainder 37. And the last step, 74 divided by 37, you will go with 2, giving you remainder 0. And the HCF of the first 2 numbers is this 37. Okay, now this 37 you have to you take with 925 the last and the third number and find the HCF between these 2, 37 and 925. Okay, here 925 is greater than 37, you will take A by 925 and B at 37. When you apply Euclid division algorithm, you will find that 925 is equal to 37 multiplied with 25 plus remainder 0. Therefore the last divisor here, 37, will be the HCF of these 3 numbers. Clear? The same thing you will proceed with the number 2 also. You will do the same way. You take the HCF, you find the HCF of 480 and 704. When you divide 704 by 480, you will go with 1, leaving remainder 224. Again 224 divide to 480, you will go with 2, leaving you remainder 32. Again you do the division, 224 divided by 32, you will go with 7, giving you remainder 0. Hence the ACF of the first two number is 32. Again this 32, find the ACF of 32 and 3680. Okay, now 3680 will be 32 multiply 115 plus the remainder, which is equal to 0. That means, which is the divisor here, 32 should be the ACF of all these three numbers. Clear? Now number 3 from here, in the same way we will proceed with this also. The first two number which is greater, 1215 is greater, therefore we'll take A by 1215 and B by 513. Now applying Euclid division algorithm, 1215 is equal to 513 multiply 2 plus 189. 513 is equal to 189 multiply 2 plus 135. 189 is called 135 multiply 1 plus remainder 54. 135 is called 54 multiply 2 plus remainder 27. And the last is 54 is called 27 multiply 2 plus remainder 0. Hence the ACF for the first two numbers is 27. And now let us find the ACF of this 27 and the third number 1134. Now between these two, 1134 is greater, therefore we'll take A to be 1134 and B as 27. And applying EDA here, you'll find that 1134 is equal to 27 multiplied with 42, leaving no remainder at all. Hence the ACF will be this last divisor, which is 27. That is 27 will be the ACF of 1215, 513 and 1134. Okay. The third problem from here, find the largest positive integers which divide 615, 963, leaving 6 remainder in each case. Okay. Now we have to understand with this. The largest positive integer when divided to this number and this number will leave remainder 6. That number cannot divide exactly to 615 and 963. Because why? Is leaving remainder. That means if it cannot divide exactly, if you minus, therefore the number should be divisible to 615 minus 6 and 963 minus 6. That means 609 and 957. That means in that positive integer will be able to divide both of these number 609, 957 without leaving any remainder, because here is leaving remainder 6. We have subtracted by 6. That means we are getting 609 and 957. That means that number which we have to find out should be able to divide exactly to these two numbers. Now which number is exactly divisible to these two numbers? It should be the ACF, isn't it? The ACF should be able to divide them exactly without leaving any remainder. Now the thing is that we have to find the ACF of these two numbers, 609 and 957. Now since 957 is greater than 609, we will take A by 957 and B as 609, and applying EDA successively, we'll have 957 is equal to 609 multiply 1 plus 348. Next 609 will be equal to 348 multiply 1 plus 261. Next 348 is equal to 261 multiply 1 plus remainder 87, and the last step 261 equal 87 multiply with 3 plus remainder 0. Hence since the remainder 0, we stop the algorithm here, and the ACF will be the last divisor, which is 87. Hence the largest positive integer is the SF of these two, which is 87. Clear? Now if you want to try whether it's exactly divisible or not, you will divide 615 by 87. Definitely you will get 6 as the remainder. And if you divide 963 by 87, there also you will find that 6 will be the remainder. It's clear? Now this is the end of this part 2. On the next class we shall discuss on the next part, which is part 3. Okay, bye to all of you.